I'd like to now move on to another part of my talk, which is Esri's work itself, what we do. We are a large software company. We work on different themes of effort, but the whole goal of those themes is to serve you with information technology that actually works. And so the purpose of this meeting for me is to get feedback about, Jack, you're screwing up there, or we need this particular thing, or like that. That's really important for me, as a matter of fact. And to kick that off, I want to share some of the big initiatives that are going on at Esri. I'll start with architecture. This is a diagram. Some of you may be familiar with it. I have my own interpretation of it. It's the diagram of a web GIS. It starts at the bottom as servers or cloud services or other open systems. In the middle is an organizational piece of software that provides access for management and identity, the support for this idea of a system of engagement. And at the top are apps. Some of them are big apps like desktops, and then browsers and apps of all kinds on devices. And this architecture has been designed to be able to run all in the cloud now, or also all on premises now, or a little of this and a little of that. So I can bring something off the cloud as a web map service and overlay my own data from a server locally. That's its design, and that's the pattern that people are using it in. Now, there is a little trick behind this web GIS that I want to share with you, and it is that it's called the Geo Information Model. The Geo Information Model it abstracts geographic data where it's at, represents it as a layer or a web map, and allows people to work on the layers and web maps without copying, without integrating into one big database the information. This is done through technology of REST. I can point at the URL for a data set, I can render it dynamically as a layer, color it, and then overlay that layer. You get the idea? I mean, it's really important to get this idea. It means instead of the database-centric approach of putting everything in a big old database can, I can actually access the weather service, like a sensor network, or the Internet of Things. I can access tabular data and map data, imagery data, and bring it together. Everybody get this idea? Okay, good. Yeah, thanks. Wow. I needed that, really. Give me some more feedback. What this means actually is that we can keep data from many different types and different agencies where it's at and bring it together and geo-integrate it. The same sort of thing that was problematic for years. This is part of the reason why this is speeding up everything. Now, in the design of this system, we understand and support the idea of an open platform to ensure this system is interoperable with all kinds of other systems. Now, the problem with an open platform is that everybody has their own definition of it. So what we've done is taken the approach of multiple pathways to support and ensure interoperability. One of those is to support all the open standards like OGC and WWW and ISO and so on, and we're active in that space. A second one, equally important, is the ability to support industry formats like DWG or the Inspire formats, so that we can directly connect our software with other software, reading each other's tools, and also do product integration, for example, directly with AutoCAD or directly with SAP HANA or directly with the Adobe Creative Cloud, so that I can be in Adobe and access the geographic information in my system. And the third is to be a strong open software platform. And here, with open APIs and open source contributions and open data access, being able to have people access our data and download it for their own use, as well as having extendable architecture and embeddable components, like we have in CJMTK and other ones here in the federal government, helps a lot. These three initiatives seem to work. The evidence of it is the thousands of systems that are operating in heterogeneous and complex environments across the world, and particularly in the federal government. I now want to drill into very specifically some of the functions and features that we're working on. First, in mapping and visualization, smarter mapping, vector tiles, 3D representations, both underground and above ground, high-powered, cool stuff. In the 3D world, a number of years ago, we initiated an effort to actually bring GIS across the entire platform, in the data models, in the browsers, in the desktop, and so on. And this was providing fast, everywhere 3D with things like web scenes, online 3D on demand, and now with full KML support. I'll next move on to a subject that's very interesting to me, which is content. For the last 7 years, we've been building in the cloud thousands and thousands of layers of information that are available to you without cost. Many of them are from the federal government. These are vector and, in some cases, tiled data sets, land cover, elevation, all the A16 layers that are basically dial tones for people with a desktop or a browser or a device, and you can build applications from them. This is a big effort, actually. And I want to take a moment and say thank you, because a lot of this data is basically your data. It's reserved, repurposed for the GIS community at large. The success of this has been remarkable. There's now billions of maps or hits against this data set every week. There's over 2 million people who subscribe to this information and get it as dial tone for their work. Directly or indirectly, you might say, those of you who are building data sets are influencing GIS users around the world. A third area of emphasis is in spatial analytics, and some of you know Desktop has thousands of tools in it. A couple of weeks ago, I guess it was last week, 10.4 released and had some new tools in it. These capabilities included high-end spatial tools like, I'll use the word Bayesian regression kriging, or exploratory Bayesian kriging. I mean, it's one of my favorite tools in the world because it allows you to take a dependent variable, let's say like landslides, and overlay it on a stack of other, in other words, observed landslides, and overlay it on a stack of other variables, and automatically develop a formula, and then apply that formula to the different layers, and show the areas where probably landslides might happen. You get this idea? And just imagine what we're about to discover. If you do this again and again, variable by variable, we can sort of uncover some of the mysteries of how the world works. In the desktop world, we also spend a lot of time integrating ArcGIS with R and SciPy. For our users now, they'll be able to have access to our databases, and for ArcGIS users, they'll have access to the powerful tools in the open source statistical package called R. These are some of the desktop initiatives. On the web side, we're also continuing to embed new spatial analytic tools to be able to do on-demand, in a browser spatial analysis, which heretofore has largely been in the desktop space. That doesn't mean the desktop is going away by any means, but it simply says those relevant analytic tools, for example, taking point data from here and polygon data from here and overlaying it dynamically from distributed data sets, is possible. And that's really cool. I can go on and on this. This is my favorite slide. But I do have another agenda. This is a very special day. This is the first time we are showing a new application in the web environment called Insights. Some of you have heard about it. This is a new web-based application that I think is going to transform understanding and working with GIS for all of you. Another area that we've been working hard on is imagery. This is the notion of being able to integrate in image processing capabilities directly into our platform. And we have definitely partners that extend this platform. However, A lot of the base tools that people really want to do in GIS are built now right into the simple desktop and server technologies. This year, we're releasing, that is this spring, a new technology for drones. This allows, it's called Drones to Maps, and it allows us to buy a cheap drone, fly it, capture the imagery, and then take that imagery and automatically create orthophotos, as well as 3D point clouds from that information. This is a very inexpensive way to do what some people call persistent surveillance. There are many tools that are emerging in the imagery world, advanced classifiers, feature extractions, but the element that I want you to really remember is the way that we are doing the image processing in ArcGIS is on demand. This is different than the traditional linear sequence of take an image, process it in its various ways, and then create an image. No, I bring an image in, and as I move around on the image, it's dynamically doing the processing on the fly. And this, in the time-sensitive environment, is changing the whole workflow of how we do image processing in the first place. Another large area of development is big data. Our team has been working for a few years on developing a new technology. We refer to it as geoanalytics, a GeoEvent Server. This allows us to take very, very large sets of vector and raster data, and process it in a space, an infrastructure space we refer to as big data. This is largely Hadoop with Elasticsearch, some tools that we are borrowing from our partners in the open source world, and build on it spatial operators to handle these hundreds of millions or billions of observations, either in vector space or in raster space. And this little picture is showing, for example, pickup and drop-off points of taxi cab drivers in New York. And you see the hundreds of millions of points. You see the little red dot turns out to be the, I think it's the best place to get a tip, right? If you're a taxi driver. That's supposed to be a joke, but you guys are what? Come on, wake up. Or on the bottom, I'll just call your attention to the same sort of thing going on in this multiple processor mini machines environment for raster data, where we're doing suitability maps with 40 billion pixels in under 16 minutes. This is sort of unheard of. Another dimension of big data is real-time data. Here, we're all reading the newspapers about Internet of Things. You know, what the hell is the Internet of Things? Little devices that are measuring everything that moves and changes. You know, whether it's a TV camera in your refrigerator telling you whether your food is spoiled or, or a stream flow gauge. I mean, people are talking about it at the Consumer Electronics Show last month I went. It's just, everything is the Internet of Things. I don't really care about the Internet of Things. I care about my things, right? And I think that's one healthy way to begin to think about it. That we are going to plug in, that is we, I mean you GIS users, will want to look at your things and bring them in as layers into the GIS frame, like trucks moving around or devices that are broken, or bring it into the GIS frame so we can overlay it and use exactly the same kind of analytics and visualization tools that we use elsewhere. Esri has built a technology called a GeoEvent Server that does that. It traditionally has been bringing in a few thousand observations a second. It's now being scaled up this year to deal with hundreds of thousands of observations a second. In other words, the connected car kind of scenario. And bringing that in and then having it also work with the whole rest of the system is the big game here. I now want to finish with a short summation of the actual product technology that these development efforts are going into. First, ArcGIS is a single integrated platform. Yes, it has the desktop and it has apps on devices and it has a server and so on. It has the online component. But from an engineering perspective, we have created it as a single open platform. So just like when you buy an iPhone, it works with the iCloud and iMusic, except unlike the Apple ecosystem, which is quite proprietary and closed, this is an open architecture that can be extended, embedded, and built on top of. This is an integrated system that has these pieces, so I'm going to talk about it in terms of pieces, even though they are integrated pieces. Apps. Apps are what's making this technology really go like crazy at this particular point. They include field apps like the Survey 123, brand new app for tabular data collection, and Collector, field navigation, a field collector tool. And new apps like Navigator, like we have with consumer technology, and also particularly I want to call your attention to one called Workforce. This will allow you to manage dozens, hundreds of field force people with an app that's geospatially related. In other words, I want you to go there and there and there, and I want you to do this and this and this. This is a low-cost and GIS-focused way to do workforce management in the field. Also, there's a series of office apps. You've seen a couple of them this morning, like the new one, Earth and Insights. These are just apps that live on the infrastructure, and Explorer and ones that you're familiar with. Another brand new one that you will see later this morning after the break is the Adobe Creative Cloud. Here, the Adobe Creative Cloud has been integrated by design to work just on the same infrastructure so that creative arts communities can build and extend on top of the web map metaphor. And then there's public apps, crowdsourcing apps, the story maps that we've talked about already this morning. And finally, the open data app that allows all the content to be able to be openly streamed and shared in multiple formats. In addition to these apps, which are simply configurable parts of the system, there's also a lot of effort that's been put into building your own app, because while we've studied hard the generic kinds of applications that people do, like field data collection, people want to build their own app. Everybody wants their own app these days. In fact, it's the most important part of what's occurring. And so there are a variety of tools, configurable templates, the web app builder, and a new product technology called the App Studio, which allows you to design it once and build an app that'll run in the iPhone and in the Android device and in the Windows device automatically, and take advantage of the native characteristics of the tools. This is going to cause explosion of access to the infrastructure. ArcGIS is designed in such a way that it is open and accessible for developers. We've put a great amount of resources into not only app builders and configurable apps, but also open APIs and SDKs that support a whole constellation of different languages for developers. Developers are, in part, our future. People that want to build apps for their own use, configure them. So in many ways, this strategy, and by the way, there is a developer conference at this conference on Friday, I believe it is, with over 1,000 developers registered that are working on and developing this on this space. Esri has also initiated an effort called the Open Source Solutions Effort. This is a team of about 40 people who build open source solutions on top of our platform. And there are some solutions in government, in public safety, and military security, and utilities. These are no-cost, open-sourced apps that live in GitHub with literally hundreds of users now at this point. There's been over 500,000 downloads of this technology, and this is for our users, but also for our developers who wish to extend our basic tools forward. We're going to do more of that this year with a community-based open sourcing technology, but I want to make the distinction that in this case, these are fully supported apps that you can configure and load and go with. The second big category of technology part of the system is the desktop, and the desktop is going through transformational changes. It focuses on two basic apps, the ArcMap app, which many of you use, but a new and emerging 64-bit app called Pro. Pro is eating a lot of the features and functions of ArcMap. Over the last couple of years, that's been evolving and will eventually take the place of ArcMap years down the road. But it actually will continue to also advance ArcMap technologies. The advantage of Pro is that it's web app focused. It's also 64-bit and very fast and has, if most of you, well, it comes out again next week in version 1.2. It's powerful, but I'll highlight some of the work that we're doing here. More 3D and 2D analytics, new tools for LAS support, concurrent Pro licensing, and then what's coming in the future is KML, more OGC support, advanced mapping, and 3D analytics. I want to finish by a couple of notes. First, the technology on the server side is also advancing. We're spending a lot of time integrating in the portal into the basic server, as this diagram shows. We're adding new capabilities for vector tiles, more OGC support. All of this comes out last week. What we're working on in the future is, this summer, a concept of distributed portals that are federated, and then some of the big data and analytic extensions that Suzanne showed. All at the same time, working on better administrative and quality and performance tools. Some of you are familiar with a concept called the portal of portals. And without laboring it very long, what we're seeing is portals develop in agencies department by department or agency by agency. And the challenge here is where do I search for information? What is coming at 10.5 is the idea that the layers, the Geo Information Model, the maps, all the items can be federated so that if I have my department's portal and its content, metadata, it'll rise up to a larger portal. And also be able to replicate itself to an external portal that might serve the public. I just wanted to make that clear that that is coming, going into beta early this summer. The last component of this four-piece description is ArcGIS Online itself. This is basically running in the cloud, GIS in the cloud, and here we've been moving along smart mapping. We've introduced formal metadata and new and powerful administrative tools. What's coming between now and the summer will be improved search, support for WFS and WMTS, and also additional analytics. I don't want to leave this conversation without describing something that is done at Esri, which is we build commercial focused applications that actually many of the people here in this room use. These are for advanced mapping and charting and specialized areas, for example, community assessment or community analysis or planning.